we have a substance decaying exponentially. M equals 300 e to the minus 0.05t. In fact, if we drew this as a graph, it would look a little bit like this. And let's find out, because we're talking about how long it takes for the mass to decrease to half of its original value, so maybe around here, then let's find out what the mass is when t is 0. And the e is just going to become 1. E to the 0 is just 1, so m is actually 300. And our graph is going to look like that. So we want to solve 100. Actually, let me just write that down. Solve 150 equals 300 e to the minus 0.05t. Okay, divide through by 300, so actually it's 0.5 is e to the minus 0.05t. And we can rewrite that as minus 0.05t equals ln of 0.5, because that's just the inverse operation of an exponential. Because when you write ln, you're saying e to the power of this thing is equal to this thing. You can alternatively take logs of both sides, take ln of both sides. You get ln 0.5 is ln e to the minus 0.05t. Bring the minus 0.05t down, and then the ln e cancels. So that means t is going to be ln of 0.5, which is going to be negative, divided by negative, so we are going to get a positive at the end. Okay, so 13.862. And that is minutes, so we'll round that to 13.9 minutes. Right, a solid few marks there. The main event is coming up. We're told that a second substance is also decaying exponentially. Its mass is 400 grams, and after 10 minutes, its mass is 320 grams. Find the time at which both are decaying at the same rate. Right, well, first up, we need to try and write an equation down for the second substance. And because it says it's decaying exponentially, it means it's going to be another it's going to have this sort of form again. But this time it's initially 400, so it's going to be 400 e to the something. I don't know what. Now I do know that it's decaying exponentially, so I'm going to put in a minus kt there. Now, for me, k is going to be positive because I'm expecting it to be minus some number that's positive t. If you put in e to the kt, don't worry, you just get a negative for your value of k. It's absolutely fine. But that's kind of your typical equation for exponential decay. With this with some sort of a or even m0 used for the initial value. But for us, we know that it's 400, so we'll go with that. We're then told that after 10 minutes, the mass was 320 grams. So I can write down 320 is 400 e to the minus 10k. Substitute a t equals 10 in. I've got another exponential equation to solve. I can divide through by 400. I'm going to get 32 over 40, which is 4 over 5, or 0.8. 0.8 is e to the minus 10k. In the same sort of way as we did above, 10k is therefore going to be ln of 0.8. So k is going to be ln 0.8 divided by minus 10. I'm just going to put that straight into my calculator. Zero point 0.02231. So M for my second substance is 400 e to the minus 0.02231 t. Okay. There is still more to do because remember it says find the time at which both substances are decaying at the same rate. So I can first of all find dm by dt for my first substance. I'm going to do 300 times, right, when we do the derivative of this, I just I multiply through by minus 0.0, sorry, 0.05, because that's essentially using the chain rule. So 300 times 0.05 is going to be 15. So I get minus, remember, 15 e to the minus 0.05 t. Okay, that is for the first substance. I'm going to bring that down now. And then the second, I'm going to get, maybe I should call this M1 at this point. That would have been a lot better. So dm by dt for the second substance, I'm going to do this minus 0.0 stuff. And I've written it down to 4 significant figures, so that should be okay. Okay, minus 8.924. Yeah, we want to find the time when the rates are the same, so we've got to create an equation and set them equal to one another. Okay, and what I can do actually is divide by e to the minus 0.05t, which is the same as timesing by e to the 0.05t. And then I can divide by minus 8.924. And the double negative will mean I get 15 over 8.924. And that's going to equal e to the minus 0.02231t times by e to the 0.05t. And these are both powers. It's like when you first learned how to deal with x squared times x cubed. You just add the powers. It's the same thing here, just like next level. So I can take my minus 0.02231 and add 0.05. 0.02769. T. What about the T nearly then? Okay, so we're nearly there, solving it. I think I'm just going to go, yeah, so 0.027 69t is going to equal ln of 15 over 8.924. So t equals divided by that answer. We get 18.754 or 18.8. minutes. I was just double checking myself because when I did this, I think I used more accuracy and got 18.746 or maybe less accuracy, but the answers accept 18.8, 18.7, or even 19. So I'm not sure. I might have lost a bit of accuracy there. I'm not too worried about that. Very technical question, got to be said. Lots to do. Okay, when you first look at it, it looks like part one looks all right, but part two has lots going on. Well done.